Hello everyone! Today in this video we will just talk about the sum of the squares of natural numbers. So I thought that how can we get the sum of the squares of natural numbers by using a geometric approach? I think we need some squares and we need to take advantage of the geometry by using the areas of geometrical shapes. Here, as you can see, I drew some squares like whose areas are coming from 1, 4, 9, 16 and 25. But how we can generalize it into n? I think it would be simpler to first think about for these 5, then to generalize it to n natural numbers. Okay, let's start. I think we completed this geometrical shape by using these unit squares, like as you can see. We completed into a rectangle. So we need to take advantage of the area of this rectangle. But how? Okay, let's start by finding the area of this rectangle. So we know actually the long side of this rectangle. Here it is a sum of 1, 2, 3, 4, 5. But for n many ones, what do we get? We get actually the sum of the natural numbers till n to find the long side of this rectangle. So what is that? N times n plus 1 over 2, right? But what is this short side of this rectangle? Here it is 5, but for n many numbers it is n. So we found the area of the rectangle. Area of the rectangle, right? Rectangle. So what do we have? Here we have the sum of these areas. This is what we need to find at the end. And here I can represent it maybe by using series from I1 to n I square. But how we can find the area of this, sum of the area of these small unit squares? As you can see here, it starts with what? It starts with the small length. Here it is 1, here it is 3, here it is 6, here it is 10. But always it has like a short side. It is 1, 1. Again, it is like that. But how we can find the sum of these little squares? Can you see the pattern actually? It is 1 to n minus 1, and it is I times I plus 1 over 3. Okay, just let's think about this pattern, how to find this sum for the sum of the unit squares to complete it into an exact rectangle. Then how we can take advantage of this series now? We have the area of this rectangle, the sum, what we need to get, what we need to find, and here's an extra term. But how we can use this extra term and our t? Okay, maybe we can just separate this extra sum into two parts. Okay, let's see how we can do it. Here we have n times n plus 1 times n over 2. Here we have our t, total sum that we need to find, and we have, maybe we can write the total sum as series as well, from I to n I square. Okay, just let me correct it. It's better now. From 1 to n minus 1, I square over 2 times 1 to n minus 1 I over 2.